Hello everyone, it's February the 4th. Alright, so we're gonna do for tomorrow. Tomorrow is the 5th and we are having a contest, right? So today it's important to finish the challenge for tomorrow, which is merge K sorted list. It's an old problem. It's on the first page, rather. And I have encountered this a few times, so I don't expect this to be too hard, even though it's labeled as hard, but I don't expect it to be hard because I think we know the solution. The solution is to put the first, the top of the list, sorted list into a heap, and every time we just pop the pop the largest out, pop the smallest out, and then we do the merge sort like that. So I don't think it's that difficult. And we must have done it many times, right? We've done many times. So we've done the first time is 2018. Wow. Those days I was very persistent, right? I was very persistent. And and I tried, oh my God, CPP. Jeez. Yeah. So, okay, here's the plan, right? So we first finish this for sure, and then I'm gonna go again for the target sum, which is like the third day, right? Today is the third day. I mean, yesterday, yeah, just like dive a little bit. Yesterday we have this solution which hit us with 99%. I was very happy, but we haven't looked into the detail yet. I think there's a solution. We haven't looked into the solution, so I want to look into the solution and see how this problem is solved, like in general case, right? In general case. All right. Anyway, so let's do this one first. K linked list. Each is sorted. Merge all into one linked list, right? So yeah, it's fine. So yeah, we can just go right into it. It's pretty standard, right? It's pretty standard solution in the current sense. It's very, very standard. Wait, hold on, hold on, hold on, hold on. I don't think I shoot. Let's remove it. I forgot to commit yesterday's code. Okay, and then let's copy today's code. Yep. All right, let's see if we can do this without any error. One shot. Okay, that could be another challenge. Okay, so we have the linked list, we have this, and we need a heap. So we're just gonna import heap, and what we're gonna do is what do we call it? We call it a, let's call it priority queue, PQ, right? Priority queue equals heap. I think we have to do this, right? And then we need to put the head. Hold on. That doesn't seem to be. Nope, nope, nope. So I have a list. So we're gonna just go through the k equals list dot length. Okay. Wait, are they the same length? No. K linked list. I have a K linked list. Each length is up to sum won't exceed. It doesn't matter. So we just loop through. Yeah, we loop through. So we say PQ equals this for head in lists. All right, so we're gonna get a head. So what do we have? Ooh, I just realized I do need all the heads, right? hold on. We put a value into it. How do we know? So the PQ has to be two things, right? It has to be two things. One is value, head dot val, and the other is head itself for heading list, right? And then we say heap dot heapify PQ, right? And then we can say dummy is equal to list node, right? Dummy is equal to list node. Then we say while PQ, right? While PQ, we're gonna pop the one out, right? So we're gonna say v and node equals heap dot heap pop PQ. So once we pop out, we put the node. Do we create a new? Yeah, we'll create a new node. Yeah, we'll create a new node. That's fine. Actually, this we shouldn't say node. Let's just call, because I want to say node here. I want to say node equals dummy. Okay, and let's just call it. What do I call it? Let's call it element. Okay, and then we say node dot next, right? Equals node dot next equals list. Oh, I want to create a new one. List node val equals v, right? And after that, I'm gonna push a new thing into it. I'm gonna say if. Hold on. So with this, and then next one we push. I'm gonna push its value in as well. So I'm gonna say if element dot next, right? We say heap dot heap push PQ. Or do we push? We push at this, right? So gonna be element dot next dot val and element dot next. Right? And then we go back, pop the next one, blah blah blah. Once we're done, we're gonna return dummy dot next. Okay. Again, this is linked list, so we cannot test on our own. Let's try see if this one covers all the cases. Not 100% sure, honestly, but let's see. That's a no. I think it should be fine. Heap is not the huh? Oh, heap Q. Damn. Yep, my bad. It's heap Q. I don't know. I don't know why I call it heap. Heap Q. Huh? Wait. Doesn't heap compare the first value, right? Wait, which one does heap? Hold on. Python heap. I think I can see here. I should have an example. Yeah, I shall be able to push this value and the node. I don't understand. It'd be based on the first value, right? Why would it complain? Heading list's gonna be this. Huh? Hold on. I mean, there's one way to solve this, but I don't want to use this. So heap queue with a tuple. I don't understand. I thought it'd work. I mean, I don't think you need to. That could be anything, right? Yeah, you need to do this, that's for sure. That's what I did. You need to evaluate this less than. I thought if it's a tuple, you automatically only check the first one. Maybe you just cannot do heapify. Oh. Oh, same value, which we do. Ah, so it keeps comparing. Wait, the documentation didn't say that? Hold on. Let's go back to documentation. I don't think it didn't say that. And the example does not have. Ah, yeah, that's a good point. That's a good point. I did not know that. Yeah, when you want to do this, something I don't really want to do, but might as well. So other, right? So what do we do? Just return self.val smaller than other.val. I think that's the yeah. And then with this change, I can just use head because it's fine, right? And then this is just going to be element popping out. Next node goes element.v.val, and if element.next push element. We just need to push element. Yes. So, but this one I have to modify. It's not something that I like, but it's something that I have to do this way. Huh? I have this. Oh. Oh, I see. I see. Oh, I cannot do it this way because the list node is defined. I think it's defined before I do this. Huh. Then how do you move forward then? Hmm. how do you move forward? I mean, I can put a value, so the value, okay, it's held, but how do I know this value associated with something? Oh, I know. I've been stupid because it's in the list. I can just push. I can push the index. My goodness. So I'm not gonna do this way. Let's do this. It's gonna be for right for I had in enumerate. Yeah, I was like, how do we do this? Yeah, we have index. All right, and a hipify, which is fine, and then blah blah blah, and then we have val v and index, right? V and index coming out, and then the next will be this is just going to be lists lists index. Oh, hold on, but I only noticed the index. Wait, hold on. This is still not right. I know the index. How do I know where I am? Oh, hold on, this is still not right. I know the index, right? And then I push this in. Then I'm changing. If you say I'm gonna pop, then I'm changing the value. If I can just move, I need another thing. That is stupid, but current nodes. It's stupid, but there's no way, right? I need to do this. So this will come this, and this will be current nodes index val, right? And after I done, we say if current nodes index dot next is good, a heap queue and a push. I'm gonna push this, right? So what I'm gonna push is this dot val and the same index, right? And current nodes index equals current nodes index dot next, something like that. So we have to use a separate. But at least it guarantees that we don't have to worry about this, right? This is not part of the problem. This one shall be right. We just use an extra array to handle. I have this issue. Oh, we can say if head, right? We can say, let's say if head. Okay. That was terrible. Hold on. Node on next is a new node. Oh, I forgot. Node equals node on next. My bad. Small error. Yeah, yeah, this one should be right. Two five. Meh. Uh, let's see. I have this solution. Was a while back. Let's take a look. Node equals node on next. Yeah. So, well, a little bit more hiccup than I had expected, right? This is 23. I had a bit more. I have done this problem many times, so the solution is well known to me. But I still had more hiccups than I'd like. For the one part, I didn't realize that I couldn't put a tuple of index and list node into heap queue. Well, sorry, it's going to be heap queue into heap queue because heap queue first compares the index, not the index, but the value. First compares value, and if the vowels are the same, it will try to compare the second element, which is list node. And list node prepared by the problem cannot be compared. Thus, we have to use index to indicate which linked list the current node belongs to. Furthermore, I had to use an extra array to store the current node for each element, for each linked list. I mean, the overall logic is not difficult. Just priority queue, just keep popping, keep adding and popping the priority queue. Yet the implementation proves to be tricky still. I'll run at 205, I believe. Oh, I'm gonna have to look at a solution. 205, 24. That will be O1 login. Well, actually, ON log K, where N is the length of linked lists and K is the number of linked lists. Okay, I'll go back to the solution, take a look. That's the old solution, right? I use a wrapper node. That is interesting. I use a wrapper node. I think the other solution uses index. Yeah, this is my current solution. I think it's the same 133 test cases. use index. Let's see how the solution using index do. So this one, I think. Yeah, wrapper. It's fine. Yeah, I think this one use index. Yeah, I have to heap queue, push val and this. Yes. Lists I equals lists I dot next. Oh, I don't save it separate. I'm changing lists. Nah, I don't like this. I don't like to change the list. You shouldn't change the list. This is the input, all right? Try to make it as pure as possible. You're changing the list, that's not pure. So no. Maybe that was from the solution. Who knows? Brute force is not gonna work. Oh, wait, brute force works. Oh, into an array. Okay. Priority queue. Wait, Python has priority queue? If output, while queue not empty, we'll get a value and a node. Wait, priority queue allows you to do that? It doesn't compare this? Huh. I do not know. Nah, just pick one. Yeah, that's true. We have to do this. We have to use a wrapper. Oh, that's what I copied. I use a wrapper. Yep. Alright, I don't want to spend too much time on this one. No, I just call it. We're good. Now with this, it's time for the big reveal. Alright? And the reveal to see what the right solution is. Brute force, 2 to the n. We have brute force. It times out. Yeah, it timed out. Recursion is simple. Recursion is very simple, but it times out. Recursion with memo. Maybe we can memo, huh? dp t times n 1d dp. Alright, let's see the dp. How does dp work? Wait, hold on. So 0, no, 0, 0, S is target. If I equals, that's different from how I would approach it. I change the target every single time. Calculate nums. Well, that's just passing this. What is I? I is, S is a target. I is the index. Sum is the current sum. So we go to the next one. I either add or I either minus. Okay, and now we have the target. And now we say if sum is equal to, you gotta be kidding me. Really? Are you saying we can DP this one as well? I have index. I have, what's S? Sum, right? I have index, I have sum, and I have target. Which is, okay, I forgot what I was trying to do. Give us index plus 1, S minus, and target minus. As for the current index, do I plus or do I minus? So I say minus, right? Or I can, wait, why this is minus 2? Wait, what's, so the current index, I take it to be positive, right? Then I have some, shouldn't this be plus? And this is minus. Wait, hold on. That is a little bit ridiculous. The first one does pass. Is minus? S is the sum. Oh, hold on. S is the overall sum. And this is a target. And I'm ditching a value. Ah, okay. I'm ditching a value. That's a lot more complicated. Ugh. Let's try. No, that's 4. Naive. It's not DP, recursion, right? Naive recursion from the official solution. This is O2 to the n. Okay, so we don't have to do any of this. We just need to set up a new function. Right? I'll say def helper. Right. So we need to know, we need to find the total ways. Right. So we need to have an index. So the start is the int, and s is current sum. Right. And now we have, say, self dot rest equals 0, and this doesn't return anything. And we say if current sum is equal to target, self dot rest plus equal 1, right? else hold on, it's not right. If start equal to n and current sum, right? So we say n is equal to len nums. So I have to go to the end, right? Else if this is this, and if, right, else start is smaller than n, then we can take, and we just do helper start plus 1, right? And current sum I either do plus nums start, and or I say start plus 1 current sum minus nums start. I will simply do helper 0 and 0 and return self.res. Let's see, number 4. Yep. So I think this is the same as this one. But it's definitely gonna time out. Sure. Right? Sure. And what we're saying is every time I have the current sum, so let's say yeah, I have value cache. I just never cache it. Huh. So what if we cache this, right? We'll say LRU cache max size equals none. This is not right. Cannot cache this value. Hold up. Oh, because this one doesn't have value. Which means, let's just change this. Let's return, right? So let's return integer, right? Let's say if this start, we'll just return 1, right? Otherwise, when you return we say from the start to the end, how many we have. It's a slightly different compared to the others. We say from, well, we have start is this position, and my current cumulative sum is this. So we say how many can we get from this, right? So once we have, so I'm looking at the start, so I don't know. So I'm at the start. I say I can put myself as a positive, and then we check. Put myself as a negative. So if I say this is yeah, I think this is plus, right? Yeah, I think it's a plus. Then let's say just return this. Will this work? Okay, so we say return 1 if else is 0. How about this? And if we do this, because it returns, so I can just do this. Holy guacamole, this might pass. This is not naive, this is a recursion with memo. And this should be O. Well, I'll have n start, and then the sum, 2000. So it's 2000 n, where n is equal to len nums, and 2000 is the largest. Sn. S is the maximum sum is all possible. Oh, I'm going to write it here. In this case, then it's very simple, right? And S is all possible sum values the nums, right? The nums list can take, right? It is at most 2000 because the sum of nums does not exceed 1000. That is the possible sums range from minus 1000 to plus 1000. In this case, then this is simple. And then you can run. I don't think it'll be like 76 milliseconds. Yeah, it's not 76, but it's pretty fast, right? Regular play, 55% ranking. But this we cannot. Actually, I've never tried it. I just thought it's not gonna work. So I have 3 levels. So it's like, nah, I don't think 3 levels can work. Madre mia. I think this one will. My recursion with memoization. We just need to memo it. You gotta be kidding me. Gotta be kidding me. Come on. Don't be like this. Jeez. The whole problem because I did not memo. I have audio cache out, but I chose not to memo. I don't understand. Why you did not memo? I don't understand. And the reason it's faster because I handle the 0 case separately. Man, oh man. Yeah, I mean, like, if we do this, then we can use memo to do this one as well. But I don't want to. Yeah, I mean, the whole idea is memoization. All right, let's do DP bottom up, right? Let's see what the fuss is about. So we have the index and the current sum. So it's like two things, right? I have to handle 2 things. It's hard to visualize without help from just drawing it out. So basically what we say is we have the sum, and then we need the starting position, right? We need the starting position. How about which one's row, which one's column? And it's the same, right? It's the same. I like to say the starting positions are the rows, okay? So it's going to be a very flat array. So starting position 0, 1, 2, 3, da 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 da. Actually, Maybe a column is easier. 0, 1, 2, 3. Okay, and then what I want is starting from this. Right, we're starting from what position, and we start at a position. Well, what are we trying to do? Right, what we're trying to do? We're trying to do is starting from this position and going all the way to the end. How many different ways we can reach the target sum? So we're gonna look at this and the target. Yeah, let's say columns are the column index are the actual index of the num, and the rows are the sum, right? The sum. We can find 0, this and a 0. You don't like it, right? No. Okay, so change it. Column is the sum. Okay, column is the sum. So I just found 0 and the sum. Okay. So to do that, right, to find that value, what we say is, if we start at 0, go to the end, we don't know, right? We don't know. But what we do know is from the end. So we're going to build up from really bottom up. The last element, right? So the last element to get to 0, that's going to be 0, right? To get a 1, so it's going to be itself will be 1, everybody else will be 0, okay? And now we go the bottom up, the second one, right? Or we can, we can go from 0, right? The 0 position, the same thing, right? We have a 1, and in the second position, right? So that's is until this one, right? Until this one, how many ways there is for each element? So we say, okay, until this one, if I set my value to 1, right? Then it's gonna be that value. Hold on. If I set my value to the plus, it's gonna go through everything and the above and all the previous value, right? Then the previous value. Hold on. So previous value say to 0 is no, is nothing, right? So if it's nothing, that can add up to this value, and I cannot have this. So it's still nothing for me, right? It was still nothing for me. So the only thing for me is whenever the previous is a non-zero, that I can add myself, and that value will be, or minus myself, and that value will be. I see. I think I can do it. I don't know why this question I was so stuck. This is actually not difficult. So bottom up, DP. Bottom up version of the same DP as in solution 4. OSN. Alright, so we need, I can do this, and then we're going to say DP is equal to, alright, nums always have length, right? Nums, yes, nums always have length. So DP equal to this for, we need 2000, right? So that's going to be 0 times 2000. Actually, not 2000, because I want to reach 2000. And reach minus 2000 to 2000, right? So that is actually going to be, I have minus 1, minus 2, minus 3 to minus 2000. So that's a 2000 value. and then 1, 2, 3, 2,000, and that's just 4,000. 4,001. Okay? Should be 4,001. Right? And then we say dp nums 0 and dp nums 0 minus, right? Hold on. We can actually do it. So when we start to do, we say, hold on. It has to be ending at this position, right? When ending at this position, so we have to add, no, this, I think this is necessary, equals to 1 and 1, right? And then we say for I in range from 1 to n, right? And then we have nums I, right? We have nums I. How do we do this? So we basically say temp equals 0 times 4001, and then for, it's actually for I in range, right? For I in range, hold on, this shall be the copy of dp, right? This shall be a copy. So for I in range 1 to 2,000, actually just 2001, right? So these are the non-negative values. Oh, we can actually go from negative. Yeah, we can go from negative. So we'll go from negative 2000 to positive 2001, right? And for each I, it has to have something. If it's 0, which means ending at this has to be j. So which means ending at I minus 1, right? So ending at I minus 1, we have nothing. So we have to be if dpj, right? If dpj, then temp something plus equal 1, and temp another thing plus equal 1 as well, right? First thing will be dpj, we're gonna plus the current value, which is nums I, right? Or actually, I don't think I need I. I can just say for n in nums 1, right? 1 to the n. And this is just going to be plus n. Or we can say dpj minus n plus equal 1, right? So when we handle, then we just return dp. Oh, okay, hold on. And when we're done, dp will equal to temp. And when we're done, what do we return? So we're going to return n minus 1, right? dp, no. Sorry, it says it is at the end, the last dp, so it's just return target. All right, let's see. Solution number 5. What the heck? That was so wrong. Ha! Wait. What is our goal? Our goal is, say we have this dp array, right? So every one represents a sum. And we have the sum from minus 2000 to 2000, right? So just cover the entire range. and for each one, and the first one, right? The first one, the nums. So we can put positive and negative, which means ending at this position. Or for these sums, I have one count, right? With one count, and then we check the next value, right? Next value. So the next value, I want to know ending at this value, what are the different counts, right? So we go through this J, right? We go through from everyone. We'll look into the DP table, and if the DP table is not empty, which means there's something in there, which means there's more than at least one, right, to reach there. So we say if we have this much reach, so I can plus myself, right? So it's just the it's not DPJ, it's J, it's J. Still not right. Still not right. DPJ, which means we have something for this sum, then I say including me, you can plus me, or you can minus me, right? And plus me, and that will be plus equal 1, because I say how many different arrangements can make to that value. Ending at, it has to be ending at J, right? Ending at J, I have this many arrangements. Does it make sense, right? Yeah, I know it doesn't make sense. Ending at, not ending at J, it's ending at this N, right? Ending at, and I want to know for this, ending at this, what's the number of, for every sum, right? For every sum, how many different combinations can we have, right? So for the previous, I have all the combination sum, right? I have all of them. I say for this, I have, let's say, 2 arrangements can get there. And for the other one, I have 3 arrangements. For this one, I have 1 arrangement, right? Now, I'm facing, I have this N, right? And then if I go through all the sums, and if I go through all the sums, what I find out is at this sum, I have a certain number, which means J plus N. J plus N shall have, I think I know. This has to be 0 times 4001. So J plus N shall equal to dpj right? That shall be dpj, because I have that many ways to get to j. So in plus n, I have that many ways to get to. But where is the? Hold on. This still doesn't really make sense. Okay, so the previous, I have a certain value, so I have, say, 5 ways, right? It's from 0 to, say, so from 0 to I have 5 ways to make a certain value. Now, I have a new thing coming up, right? New thing coming up. Okay, now I say, for this value, I can plus this, right? So, for that value, I have 5 ways to make the plus after plus, right? And then I have all these 5 ways to make these, and then also minus, right? Now minus, I have So 5 ways to make this, 5 ways to make 5 ways. Okay. So the next round. So we'll stay the same. That doesn't make any sense, right? That doesn't make any sense. It should be like an accumulating step. Where is the accumulation step? What I want is at the end, right? All the way to the end, how many different ways are for each sum, right? That's what I want. We'll return DP target. I think I might know. No, I don't. Hold on, hold on, hold on, hold on. I'm very close. I'm very close. So I want to have this target, right? And then it's target minus the last value. Oh, target plus last value, right? So if I have that many, then if I'm looking at my target, right? I'm looking at my target. Hold on. So for j in this range, shouldn't that be temp j, right? Should be temp j shall equal to shall plus equal to dp j minus n, right? dp j minus n what's the value? Value is 1000. Total sum. It's fine. J minus n. Because I can go j minus n and plus n, right? So it should plus equal to this. Shall also plus equal to dp j plus n. And of course, we have to say if j is larger or equal to n, I'll do this. If j plus n is smaller, actually no. J minus temp now there has to be j minus and j plus has to be within the range, right? It has to be within the range. Has to be within the range. Yeah, so it has to be j minus n. It has to be larger or equal to minus 2000, right? It has to be smaller or equal to 2000. I mean, we can say max sum equals 1000, right? Max sum is 1000, and this is just 2 times max sum plus 1, right? And then same thing comes here, and this is just max sum, and this is max sum plus 1. try this. Oh, oopsie doozy. Got it wrong. Oh, pass more, but we are a little bit short. Just a little bit short. Okay. The last one. Last n comes in. Temp equals this, and I handled. And after handle, I return target. Huh. Why is this not correct? I think I know. So this one must be 1, and this one plus equal 1. How about this? Both plus equal 1, just to be safe. There we go. There we go. I mean, if that